Hi there. A lot of people had a question on that very last question, so I wanted to make a video of it. We're not going to spend time on it after break. After a week of it, you probably won't remember anything out anyway, so I want to make sure to get this back to you right away. We seem to have done pretty good on number one. It was asked why would you make, what ion would you react with a barium and make a solid first? Well, barium sulfate would make a solid first because it's 1.5 times 10 to the negative 9, and that's smaller than 1.6 times 10 to the negative 9. But just barely. 1.5 versus 1.6, that is just barely. And so that's probably not enough to assume that the barium sulfate is going to be the one to make the solid, right? I mean, that's a bit tight. So to make sure that barium sulfate is the one we made, because we want to prove that sulfate ions were the ones that were making the solid, and we want to prove that sulfate ions existed, we first made an acidic solution. And so that's kind of what I want to explain. When you've got sulfate ions in the bucket and carbonate ions in the bucket, let's say you have both of them, you only want to precipitate the sulfate ones. So here's what you do. If you acidify it, then we know that this reaction is going to happen for both of them. They'll take on a hydrogen. And what we're going to do is look at the Kb for that. I'm using the Kb for it because this carbonate taking on a hydrogen is a base thing to do. Taking on a hydrogen is a base thing. Same for the sulfate. And it's the opposite of that last hydrogen being lost. So over here, if you look at the table, that would be Ka2. So if I want to find the Kb according to the Ka2, the second time the second hydrogen comes off, I got to do Kw over Ka. And so then our Ka for the sulfuric acid is at 1.1 times 10 to the negative 2. And for the carbonate, it's at 4.7 times 10 to the negative 11. So that's what I did for you in the answer key down here. Whoop. 9.1 10 to the negative 13. 13. And so we got 10 to the negative 4 and a 10 to the negative 13 number. So when I look at those two numbers, 10 to the negative 13 is really, really small, which tells me that it's really not going to want to do this reaction. It might do it a little bit, but very unlikely. When I look at the 10 to the negative 4 number, this is much more likely to actually happen, which means this carbonate taking on a hydrogen is much more likely to happen. So it will. So it'll actually form this HCO3. So this is what's actually more often in the bucket. I can't say more often in the bucket based on this Kb, but I can say that the carbonate ion concentration will definitely decrease because I'll get HCO3 in the bucket now since it reacts with the hydrogen. That means my carbonate concentration is much, much lower than that 0.05, which is what I have in all of the containers. So now that the carbonate is much lower, that means to have a barium concentration needs to be much higher, and it's much less likely for barium to react with the carbonate since it's no longer in the bucket. So that would be why the barium can still react with the sulfate, since it's more likely at a higher concentration in the bucket to react with the barium, to make barium sulfate, and thus we can prove sulfate ions were in the bucket.